All right, this is 17.21 concave mirrors. Today I'm going to introduce you to ray diagrams. Remember that this stuff is not easy. It's not necessarily hard, it's just you have to learn it. You can't just expect to know it right off the bat, so you have to struggle. You have to draw these things. You have to ask questions. There is a ton of YouTube videos on how to draw ray diagrams, so if my way doesn't work for you, go and find a way that does. All right, we're also going to give you some equations to calculate focal length and magnification. This will help you double check and make sure that you're drawing the ray diagrams correctly. So we have to go through a little bit of vocabulary first. Concave mirrors are mirrors that are curved inwards. So the front of the mirror is curved towards the object. This is a concave mirror. Isn't that fancy? Hopefully what you're seeing right now is an inverted image that's very small. Yeah? An inverted meaning upside down image. Now, I'm going to walk this mirror closer to you, and I want you to see what happens when that's closer. It's like a makeup mirror. Oh. Okay. All right, so when it's really, really close, what do you see? It's magnified, and it's upright. You see, it's upright instead of inverted. It's huge. Never ever want to see yourself up that close, right?
You're so mean.
Oh, yeah. Okay, this curved mirror, depending on your location, will change the image. We're going to find that using geometric optics. So since it's curved, normally when we talk about a diffuse surface, the light rays are all ejected in different ways. They don't actually create an image. But with the curved spherical mirror, it's still a polished surface. It just bends the rays so that the image looks a little bit different than it normally would if we were looking at like a flat plane mirror. Now, sometimes our image isn't perfectly clear, and it's not because it's unfocused. It's just because the mirror can cause some spherical aberration, which is this large diameter of the mirror. It makes it so it's not perfectly clear. This usually happens on huge telescope mirrors. And the one other thing that we need before we get started on our ray diagrams is that the focal length is twice the radius of curvature of the mirror. And what that means is this curved mirror is part of a big sphere. So if we took our curved mirror, let's say this is our curved mirror here, and this is the back of the mirror, and this is the shiny front of the mirror. If we took this mirror and pretended like it was one giant sphere, at the very center would be our center point, and it would have a radius. So the equation that I'm giving to you is that the focal length is going to be half the radius, or twice the focal length equals radius. So our focal length, this is the point where all the light waves converge, is half of this center point. Now, our mirror is not a giant sphere. It's only a portion of the giant sphere. So this is what your ray diagram is going to start out as. We need to know a few more little vocabulary variables. The principal axis, this was on your foldable that you were copying down yesterday. The principal axis is the axis that goes through the center of the mirror that's perpendicular to the mirror. So this is the principal axis. What's not up here is a mirror axis that just goes straight down into the vertical line. So you end up with a coordinate system over top of your mirror. We have the focal point. This is the focal point F. This is the focal length. The focal point and focal length are interchangeable. One just says the point, the other says the distance of the point from the mirror. You can use either one. We will just use them interchangeably. And the center of radius, that's that center. If we were to expand the mirror into a circle, that's the point, where the radius is talking about the distance. A lot of times I tend to change it up so it's 2F equals C. It kind of changes the two. It uses both. So again, they're interchangeable. One's the point, one's the distance. Doesn't really matter which one you use because we're talking about the same thing in this case. Guys ready to start with a ray diagram? The first ray diagram ever. And I guess I was sick of these. Would be great. You need to make sure that you have a ruler. You cannot freehand this and get a good answer. Your answer will be way, way, way off. It might give you an idea of where the image is and about how big it is, but it's not going to give you the right number. So you need to go grab a ruler if you don't have one. And you're going to need a ruler for like this chapter and the next chapter. Okay, are we ready to move to our ray diagram? I still see a red. Okay. Okay. So our ray diagram, we're going to draw the principal axis. We draw the focal point, the center point, the mirror, and the mirror axis. I actually do have a practice for us today, so I will do that. 1 second. I just need my ruler, right? Okay, we're going to draw the principal axis first. And my principal axis, I think, has to be really huge because of the scale that I'm using. Now this principal axis should go across the width of your page. And usually I leave about 3 to 4 notebook spaces above the line and 3 to 4 below the line. Now right down the center of your line, we're going to put the mirror axis. And that's just a straight line. Now, as you get better at these, you'll be able to decide if you want to shift your mirror a little to the left or a little to the right, depending on what kind of mirror it is. But you can start with it in the center if you're not really sure where to put it. Center is probably a good place. You can change your scale. So if it says like 20 centimeters and your page is only like 10 centimeters wide, then you're going to want to put it to a scale. If you change the scale, make sure you put the scale up here. So what scale we're going to be using today on this ray diagram, you're going to be doing 1:1, and mine is going to be 10 centimeters is equal to 1 centimeter. That's my scale because I'm using a meter stick instead of a ruler. Okay, our practice today says draw a ray diagram of a concave mirror. So we're using a concave mirror. We're going to just put a representation of a concave mirror over top of it. Now when we do our rays, we will not be bouncing off the curved part of the mirror. We'll be using the mirror axis. So this curve that you're writing, it could be a really tiny curve, it could be a really big curve, it could be a really, really, really big curve. It doesn't matter what your curve is because you're using your mirror axis. The curve just reminds you that the focal length and the center point are going to be on the left. That's its only point. And also that it's a mirror, because you'll see that lens diagrams are very similar. Okay, now, the next part of this says, the ray diagram of a concave mirror with a focal length of 2 centimeters. So our focal length, 2 centimeters. It says the object, so an object, that's supposed to be P. Object P, and it's going to have some sort of object height. P is 5 centimeters in front of the mirror, and it's 1.5 centimeters tall. So 5 centimeters for P, 1.5 for the height. We're looking for the image location, the magnification, and the image height. Now, we've already got one little equation here that says 2F is equal to C. This is the first one you want to use. If 2F is equal to C, what's C? C is 4. So now we have everything that we need to start our ray diagram. So we have the principal axis and the mirror axis. We need to draw in F, C, and our image. So measuring from the mirror axis, the straight one, not the curve, because your curve could have any curve to it, we are going to measure our focal length point, our focal length first. It's going to be 2 centimeters in front of the mirror. So from the mirror axis, you're going to go 2 centimeters and call that F. And you don't need to write this 2 centimeter distance. That's just for the people that get lost. Okay, the next thing that we're going to do is we're going to measure for C. C is 4 centimeters in front of the mirror. So put your ruler up, find 4 centimeters, and label it as C.
Wait, what did you just say?
We're measuring for C. So this distance from the mirror axis to C should be 4 centimeters.
So you don't go from the top, right?
No. Always measure from the mirror. Okay, next one, P, 5 centimeters from the mirror. So from the mirror, go 5 centimeters out. And that should be here. And that is P. Then you need a smaller scale. Or you can just shift everything to the right a little bit. That's probably what I would do. All right, and the last little thing that we have, HO, that's the height of the image. So put your ruler right where P is, and you're going to draw 1.5 centimeters up, which makes mine like really super tall. This is 1.5.
And do we label that as HO, or do you not?
You don't need a label. Yeah, you don't need the little labels that I'm putting either. Just the FC and P is fine. I just put the little label since it's your first time. Why, bro? Now this is the setup of the ray diagram. From here we're actually going to draw the rays. So I need to know that you guys have gotten all of this and know how to set this up, because this is the first part. Does anybody have any questions?
And then C is 2F. I asked her, but does it matter where you put the height? And then P is height lines like that's given.
It should be 1.5 centimeters tall right on top of P.
Always on P?
Always on P.
So it's never going to be on F or C?
No.
So you
P is your object. These are points based on the mirror. So P can move wherever it wants. F and C is dependent on the mirror. So F and C are like the focal point of this mirror right here. And as I move this mirror closer, right, you're P. So you can move. And your height can. Okay, you guys ready for the race?
Yeah.
Nobody has any questions yet? Okay. We're going to draw the first ray. The first rule is parallel and then through F. So I'm going to write that down over here on the side. The rules for rays. Our first ray is going to be parallel and then through F. So from the top of your object, which is P, which is this little arrow that we've drawn here, we're going to go parallel until we hit the mirror axis. Okay. I'm erasing invisible lines here because it doesn't like the fact that I have a meter stick on the board. Oh, goodness. Hopefully that'll work. And I'm just going to draw right over top of it. It's close enough. There's like this big red line there. Oh my goodness. Okay, the YouTube video is going to look terrible. Alright, that's the first part of the ray. So we did the parallel part. Now we're going to do the focal length part. Now I want you to line up where you hit the mirror at. Now again, it's the mirror axis, not the curved mirror. And it's not this point where it crosses, because it could cross anywhere. It's where this parallel line hit the mirror axis. Line that point up with F. And on the left side, it's going to be a solid line. And on the right side, it's going to be a dotted line. Okay, let's see what this did. It worked. Kind of. I'm going to come around. If you want me to double check that you did it right, just snag me.
So is this supposed to be like straight, or is it supposed to be like this line? Parallel. So does it have to go like at a slant, or does it have to be straight?
You're just wherever this is.
And then when you cross x-axis,
Oh, okay. I thought it was supposed to be slanted.
Mine is a little slanted because I'm trying to get it to behind.
okay, but this is what they're saying. Anyone can walk in because they're not going to know what you're.
So it should be like straight or perfectly parallel.
So basically, and then where you hit, that's when this one. Yeah.
And then if they say, who you put to this? So you draw arrows.
Like, I'm here to
I mean, it's show them.
You draw arrows like yours. And if you want, I don't.
Does it matter?
It's just more stuff to go into your diagram, and then
I can do a whiteout. just gonna like.
Copy. Now it's going to pass the test. I'm passing the test or not?
I would just send this line.
Just need to see. No, I don't need to do stuff. Well, I'll do your science.
Flowers missed it. So you want to move
I
this
take two
line.
classes. How's that?
Yours, you might want to extend it.
I need English.
Okay, anybody concerned about their line? All right, the next one is really easy. It's my favorite one because people tend to not forget it. Go through C. You know, from the top of your object, you're going to line it up with C. So from here to here. And this one, no dots or anything, just a nice straight line. Straight through C. Easy peasy.
Do you go above P?
Nope, should be right through P. Or right through the very top of P. Mine's off a little bit because I got expo markers.
So you go through it?
Through the very top.
How come you don't do that when you do the other one?
I did. Started at the top of me.
No, but that one you go above it.
Oh, sorry.
Oh, you weren't?
It's expo pens and a meter stick. They slide when I write.
Oh, okay.
So yours are going to be better than mine.
So we start right here and just go straight off.
Should be always measuring from the top of P. Mine looks like it's a little bit off. It's because it's an expo pen and a marker and a whiteboard, and I'm drawing like this instead of like this, so gravity works against me. But it's always from the top of P. And that one looks like this. We got a nice, from the top of P, straight down through C. Well, not straight down, but at an angle. And you should get this nice crossing point right here. That's what we're looking for. So if you don't have this cross point, you probably need to extend this line a little bit longer. Okay, questions on Ray 2? We're almost done. Ray 3 is the opposite of Ray 1. It is going to be through F and then parallel.
Are you supposed to put arrows at the end of everything?
You don't need to, no. I did here because I'm trying to... It's supposed to be like a standalone PowerPoint so the people that weren't here have it. And it shows you drawing from here to here. But I don't put the arrows in them. Obviously, you can see mine. Okay, so this one, we're going to line up the top of the object with F and draw till you hit the mirror. Stop when you hit the mirror. So the top of the object through F. Make sure these points line up.
The mirror axis or the mirror?
The mirror axis. The mirror is only a representation. Do not ever bounce off the mirror itself because you could make the curve any curve you wanted to.
Yeah,
That's why we don't use it. It's just to remind us that the F and the C should be on this side. Now, once it hits the mirror, you're going to go parallel. It bounces off the mirror parallel. On the left, it's solid. On the right, it's dotted. The dotted says that it's behind the mirror, so it's a virtual image. The solid part says it's a real light ray. It's on the left, so it's going to be a real image. So wherever you hit the mirror at, you're going to go parallel. Oh, man. Mine is really bad. It's because that one's wrong.
Is this the virtual image?
This is a real image because it's on the left. Parallel. Okay, mine is not very good.
Is there any specific spot that we stop at?
It just needs to cross. Yours should line up right on top of the X right here. See where my red and blue line cross? My green one should actually cross right over top of it, but I really messed up my red line when I drew it because of the E-beam. So you're going to get something that's like right over top.
If we don't, is it fine?
It depends on how far. No, yours is fine.
Like right through here.
Yep. Yep, that would be a problem.
Miss Phillips, when you said you needed pens, were they blue pens or black pens? Or any?
Ballpoint pens? Either. Okay. And so the solid is on the left and the dotted is on the right. I don't even know if it got that. It didn't even get it. Dotted on the right. There we go. Now, on my ray diagram up here, because this is slanted, the red one's kind of slanted at the top, my lines don't converge like they're supposed to. But since you're doing it on paper with gravity and not big fat pens, yours probably lines up pretty good. If you look at yours, it lines up pretty good. Does anybody want me to take a look at theirs just in case it's wrong? Anybody else? Not sure. Okay. Yeah, you can do it. But it's close enough that it's fine. Oh, no, it's not. Right here, yeah, yours is good. Yeah, yours is pretty good. Yours kind of looks like mine.
Basically, what do we
Alright, anybody else want to look at theirs? Alright, we're almost finished. You should look at this little cross point where all three of your rays converge. And now we're going to draw the image. The image, at this point, right here, where they converge, which yours is converging a lot better than mine, so I'm kind of picking a spot that's in between, draw to the principal axis. It's below the principal axis, so our image is inverted. This is our image right here. This is Q.
Wait, Phil, do you find the point where all of them converge?
Uh-huh. And you're going to draw to the principal axis.
How would...
So like hers.
there?
Yeah, draw all the way up to the principal axis. Structure it.
And then, wait, what did you say if it's under...
If it's under, then the head of the arrow is going to be down there.
So it's going to go...
It's going to be pointing down.
But then, if it's, you said if it's up here...
Yeah, if it was on top, then we would make it... Like, for instance, if our converging point was up here, then we would draw it like that. But for these ones, anytime it's on the left for concave, it's going to be upside down. Anytime it's on the right over here, it should be right side up. All right, BCC, you guys got to go, unfortunately. But this is Q, and you can measure Q from here to here, and your HO is going to be the height of this arrow. And then if you want to take a look at the PowerPoint, there's some equations there to double check it. But this is the ray diagram.
Is it 1 centimeter?
I got 1 centimeter when I did it. It was like 1.1 when I did it. So what we're going to do is we're going to measure Q. And I get 3.3. Q measured is 3.3 for me. It might be a little bit different for you. You could get 3.1. You might get 3.4. Write down what you get.
Whoa.
3.2 is fine.
Wait, we're measuring
From Q, from the arrow that you just drew downwards, all the way to the near axis. 3.4, that's fine.
Is this how our test is going to be? So we're just going to draw random ray diagrams?
They're not random, but yes.
You know what I mean. So then, if we're off like a little bit, like a couple
It'll
of
be
times,
fine. You're going to do the math too, so you'll have to double check and see that it's close. So I'll be looking at the picture and make sure you do it right. And you know if it's a little shift here or shift there, you're fine because you still have all the components. All right, and then we're going to measure the height of the image. So how tall is that arrow? And I get 1.1 when I do this. So my HI is 1.1. It's upside down, so it's negative.
What is HI? Is it like the image? Is it image location?
It is the image height. The image location is Q.
It's pointing down, just like.
It's pointing down. So that makes it negative. Its height is upside down. All right, and that is, sorry, skip ahead here. Draw the image from the principal axis to the converging point. Since it's below the axis, it's going to be pointing down. Anytime your object is past the center point, you're going to end up with a smaller image somewhere between F and C.
Wouldn't Q be negative Q because it's pointing down?
No, Q is positive because it's on the left side of the mirror. It would be negative if it was on the right side.
Oh, so regardless if it's pointing up or down?
Yeah, the up and down is taking care of H.
Okay.
All right, if we move our object closer to the mirror, look what happens to the ray diagram. It's still upside down, but now it's the exact same side when it's sitting right here on C. As it gets closer to you, it gets bigger, but it's still inverted. This is like when I'm moving it towards you. It's getting bigger and bigger and bigger. And then it comes to this point where you can't really even see anything. And that's when you're at the focal point. And then if you get really close to the mirror, like really close to the spoon, you see your huge nose in the spoon. Just like when I bring the mirror way up close to you, you have to see your face, and you're like, whoa, look at that. And then it becomes upright and virtual. It's inside the mirror. And it's really big. All right, so let's double check. We're going to double check our ray diagram and make sure we did it right, because this is a lot of work for it to be wrong. Right? The ray diagram is worth like 10 points. The math part's only worth 1 or 2. But if our math parts are saying the same thing as our ray diagram parts, then everything's good. We get our full points. So we have 2 equations. The first one here is our focal length equation, which I actually need to write on this side. 1 over F equals 1 over P plus 1 over Q. So let's double check this. We were given F and P, and we found Q using our ray diagram. So let's put F and P in here and make sure our Q comes out to be something similar. It doesn't have to be exact, it just has to be pretty close. So 1 over F, F is 2, P was 5, and equals 1 over Q. So this would be 1/2 minus 1/5 equals 1 over Q. We put this in our calculator, which we don't actually have to do fractions because we have calculators, right? 1 divided by 2 minus 1 divided by 5. 0.3. A lot of times, people get to the test and they leave it like that. I can't give you full credit for that. You didn't solve for Q. We get stuck. It's pretty easy. It's flip-flop the bottom and the top. Q is equal to 1 over 0.3. So just do 1 divided by your answer. And now you get that Q is equal to 3.33. So, does that work? Does that match what you have written? It matches mine, but mine could be off because it's on the whiteboard. So if yours is 3.4, it's fine. It's close. If it's like 7, probably did something wrong. And you need to go back and fix your ray diagram because that's what's worth points. This one's just a double check. But you should do it anyways. All right. One more thing that we can double check is the height. Magnification is equal to high over ho, as in hi-ho, hi-ho. I guess Cheerio. I haven't heard that one before for sure. And then it's also equal to negative P over Q. So you can do magnification with high over ho and get an answer, and magnification with negative P over Q and get an answer, and make sure the two answers match. If they match, then you know your heights are fine. Thank you. I always write it the wrong way. Oh, negative Q over P. Negative Q over P. Thank you. Always doing that. All right, so let's put in high over ho and make sure it works. We have negative 1.1 over 1.5. And that gives us 0.73. Now I'm going to put in the other one. We have negative Q over P, which is 5. So 3.3 divided by 5. Negative 0.66. It's a little off, but it's pretty close. Doesn't have to be perfect, just have to be pretty close. Now if I was getting something like 0.13 and 0.95, okay, that's a little bit of a leap. But this one, it's fine. It's close enough. So now that I've checked this with what I've gotten from the ray diagram, I know that I've probably done my ray diagram correctly. Any questions about this ray diagram? It's not too bad, but you got to draw it to get it. And it lets you learn how to draw it and go through these rules. There's no way you can fake it. Because I'm looking at the picture, and if your picture isn't right, then I know you didn't do it right. All right, here we go. Here's your homework. It's going to be 12 through 16 down here. Make sure you're looking at the honors physics part. And it only asks for, the numbers. I want you to draw ray diagrams for each one. You should be doing this process for all 5 of these questions.
Okay, Miss Phillips, HI is the distance from the x-axis to wherever they all converge.
Yes.
And then the Q is from that point to the y-axis.
Yes.
Where you have the last equation for the end, where it says, it says 0.66. The arrow that's next to it, is that with that, or is that with the?
Nope. That was me explaining, like, if it was above the x-axis, then it would be upwards. But no, it doesn't. It's not really there.
Thank you.
Are we allowed to use the foldable on the test?
Yes. You can only use the foldable, though. No cards there. Only use the foldable, no cards.
I didn't get the worksheet or the handout.
Do you need the paper too? Oh, no, that's
To be honest, probably.